Anodizing aluminum is an electrochemical process to convert the metal surface into an anodic oxide finish that is durable and highly corrosion resistant. The anodic oxide structure originates from the aluminum and is composed entirely of aluminum oxide. In simplest terms, the aluminum oxide is grown from the underlying aluminum substrate. It has a highly ordered structure that is well suited for coloring and sealing. Unlike paint or plating, the finished anodized surface will not chip or peel. The anodizing process consists of immersing the aluminum into a tank of sulfuric acid electrolyte while passing an electric current through the medium. A cathode is mounted to the inside of the anodizing tank, while the aluminum extrusions act as an anode. Here, product is being racked for the first part of the anodizing process. The aluminum to be anodized is loaded onto carrier racks, which provide electrical conductivity through the material. Oxygen ions are released from the electrolyte to combine with the aluminum atoms at the surface of the material being anodized. Anodizing is, essentially, a form of highly controlled oxidation, the enhancement of a naturally occurring phenomenon. The anodizing process can consist of up to 5 individual steps: cleaning, etching, anodizing, coloring, and sealing. The first step is a pre-treatment cleaning process that removes grease or oils, which can interfere with the anodizing process. This is accomplished by submerging the aluminum into an alkali or acid-based detergent bath. Removing the grease or oils left over from the extrusion process is critical to ensure that there is no spotting or uneven etching of the metal surface. The material, which can be up to 30 feet in length, is then rinsed in preparation for the next stage in the process. Caustic or acid etch is used to remove minor imperfections and prepare the surface for anodizing. A thin layer of aluminum material is removed to create a uniform surface ideal for anodizing. The etching process also provides the uniform matte finish seen in the final product. The material is then rinsed again in preparation for the anodizing step. This rinse is known as desmutting and is designed to remove any residue from the etch process. After additional rinses, the material is transferred to the anodizing tank and immersed into the electrolyte of sulfuric acid. An electrical current passes through the tank, causing the release of oxygen ions and the growth of the anodic coating. The anodic coating both enters the substrate and grows outward, creating a fully integrated layer. The anodizing process generates a lot of heat, so the electrolyte must be refrigerated to maintain the proper temperature. Immersion time is carefully monitored, since this is how the desired thickness of the coating is achieved. Periodic testing ensures the proper results. Following anodization, the material is rinsed in deionized water to remove all minerals that could cause spotting during the final steps. If the product requires color, it will be added at this stage. The newly created anodic coating is a porous structure. Dissolved metal salts or organic dyes can be introduced into the open pores to create various shades. The final step of the anodizing process is to seal the porous surface using a solution of nickel acetate. Sealing closes the pores, providing a uniform sealed surface. This final sealed surface is very durable and provides color that is long-lasting and integral to the surface. In addition, anodizing is the reinforcement of a naturally occurring oxidation process and produces no harmful or dangerous byproducts.